Okay, so moving on, you might see it written as like a table. So maybe we'll have the function f of x is equal to 2x minus 12. Right, and then you might see a table that's like this. And you actually did this again in the second week, because essentially that's what we were doing up here in the previous video, where I'm just plugging in for different values, right? So now it might be blank, maybe it's filled in for you, but I'm just gonna pick values for x, right? So I want to know what's f of 0. I want to know what's f of 1, what's f of 2, what's f of 3, right? So what's f of 0 equal to? Again, my function is up here. So 2 times 0 minus 12. 2 times 0 is 0, right? Minus 12. 0 minus 12 is negative 12. Okay, then I want to find the value of the function when x equals 1. So again, I'm just substituting it in. This time we're just writing it as a table. We were doing this before in the previous video. I'm just writing it in a table form now, which will come in handy when we get to graphing next week. Right, and be a good idea to like circle your answers. 4 minus 12 equals negative 8. 6 minus 12 equals... Okay, so that's it in table form. When we do graphing, instead of writing f of x, you're going to write y. But it's the same concept. You'll just like plug in values and then you plug the x into the equation and you solve for y, or you solve for f of x, right? F of x and y, pretty much the same thing, right? So then if we're using the same equation, we'll get all the same answers. Okay, and if you notice, so if you look at this, you can pick whatever numbers you want when you're plugging into x, but I always like to just, you know, stick with small numbers and go up the same increment. But, right, every time it's going up 1, right, plus 1, plus 1. And now if we look here, what's happening here? Increasing by 2, increasing by 2, increasing by 2. So what these functions are representing are patterns. These patterns actually represent slope when we get to graphing, but don't worry too much about that now. Oops. But we're noticing a pattern that every time x increases by 1, right, f of x increases by 2. Right, so I could, once I figured out the pattern, I could just keep filling this table out, right? So if I had a 4, then if I use this pattern, then I know my next one's just going to be negative 4, right? If I wanted to keep going, sorry, it's kind of running out of room, 5, then it would be negative 2, right? We could keep going. I can use this pattern to predict the next values for x, right? So these patterns are really important. We use them all the time. We use functions like this, well, not like this, but functions and their patterns to represent real life data, right? So like how they get projections for the election and things like that, right, is based off of patterns. And they notice these patterns and then they can make predictions, and sometimes those predictions can be really spot on, right? But they even use it in medicine, scientific research, data, things like that. That's where functions really come into play, but we're just doing really basic examples, right? So once you notice that pattern, you don't have to even do all of this substitution. You can just plug it in. Sorry, it got really messy there. Right, so let's just do one where we're actually given all the values in the table, and let's see if we can spot the pattern. One. Right, so then x increases by 1. Every time x increases by 1, then f of x also increases by 1. Right, so we know that pattern. That way I can actually make predictions. And we'll learn how to make equations from this later. But right now we're just going to see the pattern. Right, so I know that's probably going to be 7. This is going to be 8. Right, I can keep going. I can go the other way too. If I'm going to decrease x by 1, so let's say I did -1, then probably my f of x will also decrease by 1, right? So that would be 2, because 3 minus 1 is 2. Right, so we can spot patterns here. Oops, that's not what I meant to do. Oop. Okay, so let's try and fill in this missing number here based on the pattern. So every time x increases by, looks like 1, right? How much is y increasing by? Sometimes it might be decreasing, right? This is by 3. So that means the next one should be up by 3. So if x is 3, y, or sorry, I should say f of x. I skipped to graphing mode. F of x is equal to 11. Okay, so we're essentially noticing patterns. We're noticing trends. So this could represent like, you could think of it like hours worked. As your hours work increase, then your pay increases, right? That would be like an example of it being used in real life, right? As hours increase, x increases, that represents the number of hours. Then f of x, the function for how much you get paid based off of how many hours you work, the value of it increases too. Okay. Maybe you have a function that's like this. Maybe this represents the money you spend, right? Okay, so if you spend $0, you're still going to have $100 in the bank. If you spend 1, you have 99. If you spend 2, you have 98. Right? I mean, it's a really basic, simple one. But what it's representing is that the more money you spend, the smaller, or the amount of money in your account decreases, right? So this is like the money in your account. This is how much you spend. This is the total after, right? That's the value of the function in terms of how much you spend. The value of how much is in your account, right? So, I mean, it makes sense, right? For every dollar I spend, then I'm getting $1 less in my bank account. Really basic example of a function, but hopefully that makes functions really clear for you. This is just where now you have an input and an output. Every time you put in a different input, a different x value, you get a different f of x value, a different output.